Hey everyone, so today we're going to work on Fundamental Theorem of Calc Part 2. If you're wondering what the Fundamental Theorem of Calc Part 1 is, if you forgot, that is just this general idea, okay, a very important idea, that if we take the antiderivative of little f of x, and we say f of x is that antiderivative from a to b, okay, we get f of b minus f of a. So this had to do with definite integrals and just being able to calculate them by hand and knowing that fundamental theorem of calculus part 1. So very important connection here. So part 2 just is another, obviously, fundamental theorem. So we're going to try this out. Actually, the first about 6 problems, we're going to do like the whole process. And then I'm going to try to see if you guys can see a little pattern or shortcut. So what we're going to do first, I'm going to try to color code this. Okay, I will first take the integral, okay, evaluate the integral, and then I'll take the derivative of what I got. Okay, and maybe you see a connection already. I'm taking an integral and then taking a derivative, taking an antiderivative, then taking a derivative. So what's happening here? We have that idea that those are going to somehow affect each other. Okay, so first thing here, like I said in blue, I'm going to take the antiderivative. So whose derivative is cosine? That would be sine of t from 0 to x. Remember, you always do the first one, sine of x minus sine of 0. Okay, and we get y equals sine of x, and sine of 0 is just 0. All right. One other thing to note, okay, you don't need plus c since we're dealing with definite integrals, right? So the second step here was then, what is dy dx? So from what you just got, take the derivative. Derivative of sine is cosine of x. Okay. So let's try the next one here. Okay, y equals, all right, antiderivative of 3t squared minus 2t. Raise the power, so t cubed divided by the new power. So divided by 3. So this would just be t cubed minus t squared. The 3 and 2 will end up canceling. You get from 2 to x. Okay, this gives us x cubed minus x squared minus 2 cubed minus 2 squared. So overall, x cubed minus x squared, and then this would be 8 minus 4, which is 4, so minus 4. Okay, so that's us taking the antiderivative. Then when we take the derivative, so what's the derivative, again, of this right here? That would be 3x squared minus 2x, and then just plus 0, or you could just not write it. What you're looking for is a connection between this guy and this guy. Take a look up here. This one, 3t squared minus 2t, 3x squared minus 2x. Okay, take a look at how those connect. We'll try a couple more here. Okay, how about the antiderivative of secant squared? Okay, antiderivative of secant squared would be tangent of t from 3 pi over 4 to x. And this would give us tangent of x minus tangent of 3 pi over 4. Tangent of 3 pi over 4 is negative 1. So y is equal to tangent of x minus negative 1. All right, and I switch my color here. Taking the derivative of that thing you just found. Derivative of tangent is secant squared of x. Derivative of 1 is 0. Again, notice here, secant squared of t, secant squared of x. Hopefully you're seeing the pattern. Okay, we're going to try a few more. For number 4, and then number 5 and 6 will have a little bit of a twist here. So take a look at 4. We're going to do the same process. So first of all, I would rewrite this as 2 times 1 over t. Okay, the reason is, right, if we try to raise the power of t to the negative first, we get t to the 0th. And we should be aware this is a special one. It's natural log. So y would be equal to 2 antiderivative of 1 over t is natural log of t from negative 3 to x. We would get 2 natural log absolute value of x minus 2 natural log of 3. Absolute value of negative 3 is 3. Okay, so that's what y would be equal to. 2 ln 3. 2 ln 3 is just a constant. So when we take that derivative, we would get 2 times 1 over x minus 0, aka 2 over x. Again, connection to here, connection to here. Okay. So take a look at 5 and 6. Okay, 5 and 6, the last ones we're going to do this whole process for so that we can see what's going on, see that connection. So first of all, whose derivative is sine? That would be negative cosine of t from 0 to 5x. Okay, and I would get negative cosine of 5x minus negative cosine of 0. Okay, and this gives me y equals negative cosine of 5x plus 1, right? Cosine of 0 is 1. Okay, when I take the derivative, the only change here that's a little bit different is derivative of negative cosine would be negative sine, so positive sine of x, 5x, excuse me. The fact that it's 5x, guys, times 5, right? Plus 0, derivative of 1. So the only change here is we had to do chain rule. Okay, so we end up with 5 sine of 5x. I don't know why I wrote that like that. How about 5x? There we go. Okay. Still looking for a connection between sine of t and then somehow we got here, 5 sine of 5x. All right. And number 6. Okay, e to the 2t. If we take the antiderivative, that would be y equals itself times anti-chain rule. That's where the 1/2 is coming from 4 to the 3x squared. Okay, and that would give us, let's see, e to the 6x squared, so 2 times 3x squared over 2, minus, I did not give myself enough room, let's move this, minus e to the 8th, 2 times 4 over 2 still. All right, aka y equals e to the 6x squared times 1/2, that's just what this is, minus e to the 8th over 2. This, again, is a constant. E to the 8th is just some number. So take the derivative there, okay, dy dx, we would get 1/2 e to the 6x squared times derivative of the top of the exponent, excuse me, so that would be 12x, okay, minus 0. 12x and 1/2 cancel out a bit, so we get dy dx is 6x e to the 6x squared. Okay, so again, looking for these connections. So let's see, I actually want you guys to pause the video here, okay? 7, 8, and 9, see if you could guess what's gonna happen. Look at above, 1 through 6, okay? Pause the video and see if you could get 7, 8, and 9, or at least an attempt at it. Okay, so now that you've tried these, we're gonna try to see that connection. So look back here, what happened? We had cosine of t became cosine of x. 3t squared minus 2t, 3x squared minus 2x. Secant squared of t, secant squared of x. All we're doing here, guys, is taking this top number, x, 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 and just plugging it in wherever we see t, okay? The reason for that is we're really doing the derivative, d dx, of an antiderivative, and they end up canceling. So pretty much we just plug in the top numbers. That happened here, right? X, I plugged in, I got 2 over x instead of 2 over t. Now, the only weird one was I plugged in 5x, so these are important ones, okay, a little bit different. When I plugged in 5x, that was the same, so instead of sine of t, I had sine of 5x, but I also have our friend chain rule, so multiply by the derivative of 5x. So this is important. You're going to multiply by chain rule of the top. So how about this guy? This would be 6x is its chain rule, so that's where this 6x is coming from. I plug in, okay, still the same thing. I plugged in 2 times 3x squared, so 2 times 3x squared is 6x squared, and then just multiply the front by the derivative of the top value. Notice that these never mattered, right? 0 versus 2 versus 3 pi over 4 versus negative 3 versus 0. None of those ever came into account because we got a constant, right? There's a constant, and then when we took the derivative, it canceled. We got a constant, it canceled out. We got a constant, it canceled out. So that bottom number doesn't matter. As long as it's just some number, okay, that's fine. It doesn't really affect our final answer. The really important part is that variable on top. We're going to plug it in and then multiply by chain rule if needed. So let's actually try these with the shortcut now. Okay, so what you're doing is technically taking the derivative of an antiderivative, that's why we're canceling, Okay, we're going to plug x in, and that's literally it. And the only thing you'd have to do is multiply by the chain rule of x, which is just 1. So you just get dy dx is x plus 2. All right, let's try this one. Take 2x. Okay, I'm taking the derivative of an antiderivative. They cancel. The 4 doesn't matter. The 0 doesn't matter. We can see from above it just ends up canceling. So plug in 2x here. So dy dx would be, okay, 2x to the 4th plus cosine squared of 2x. Okay, now notice I'm putting bigger parentheses because the last thing I have to do is multiply by the derivative, okay, of 2x. You don't have to write it that way. You could also just say, okay, times 2, right? This derivative is 2. That's what I'm multiplying at the end. So I'm not looking at this for chain rule. I'm only looking at the top limit of integration, okay? So if you want to simplify this a little bit, you end up getting 16x to the 4th plus cosine squared of 2x all times 2. So 32x to the 4th plus 2 cosine squared of 2x, if you want to write it that way. Okay, this is technically fine for your response. All right, and then let's try one more where we're doing this shortcut right away. And that's the whole point of this, guys, is we're never going to have to do this whole looping thing where we do both. We're going to be able to see that, oh, it's looking for the derivative of y. So taking the derivative of an antiderivative cancels. I plug in x cubed anywhere I see a variable, the variable that's t given. So e to the x cubed squared minus cosecant of x cubed. And again, oh, this is in a square root, my bad. Okay, so exactly what it says here, plug it in, times what? Times the derivative of the top limit, so times 3x squared. Okay, so that's where you're doing, it's a little bit confusing. People want to try to do chain rule from here. It's chain rule from the upper limit of integration. That would literally be it. If you want to rewrite it a little bit, you could say dy dx, 3x squared times the square root of e to the x to the e to the x to the 6th minus cosecant of x cubed. Okay. So that's it. Let's go, if we look in the next page, we're just going to kind of summarize this, actually try this with a couple more problems. Okay, we're just going to try 1, 2, and 3 below. So take a look. Okay, here's your official writing of this. If you're taking the derivative of an antiderivative, you take u, plug it in for anything we see t, and don't forget to take the derivative of the top limit of integration. All right, so that's what we're going to do down here, and this is how you'll see fundamental theorem of calculus part 2 shown to you. You'll see the derivative of an antiderivative. They cancel. You take 3x and you plug it in for u. So cube root of 3x squared minus 5 over 3x cubed. Okay, again, I'm plugging in 3x, and I have to multiply by, what's the derivative here? Times 3. Okay, again, I'm not doing chain rule of anything else except for this top level of, the top limit of integration, excuse me. Okay, you can rewrite that if you want. I'm just going to leave it for now, unsimplified. Okay, so derivative of an antiderivative, they're going to end up canceling. Again, we don't care about this constant in the bottom limit of integration. Again, that 3 is connected to that top there. So very similarly here, anywhere we see a t, we're plugging in the limit at the top, those cosine of x squared minus x. Okay, so I saw a t, I plugged in the top limit. Don't forget, multiply by the derivative of this. So chain rule with that, which would be 2x minus 1. And that's it. Okay, last one here, number 3, we're going to try together and then we'll be all set. Okay, we are going to try to find the second derivative actually, and it's a little bit changed. You'll notice cosine of x is here and 0 is there. So I hope the first thing you're thinking is we should switch these because we want, it's backwards, we want that variable to be on the top. Remember, when we switch, we throw a negative out front, okay, 2t dt, okay, and if we're taking the derivative, again, of a antiderivative, these cancel, the negative is still there. Maybe I should put the negative inside so you guys can see it. The negative is there. These cancel out, and I'm plugging in cosine for t. And I'm going to have to multiply by the derivative of cosine, which is negative sine of x. So let's try this out. So plug in, so negative 2 instead of t. Instead of t, I have cosine of x. All right, that part is done. Times chain rule. Okay, that is simply just times negative sine of x. Again, it's chain rule of the upper limit of integration. So dy dx is positive 2 cosine of x sine of x. All right, and then what we're going to have to do is find the second derivative. Now, we're done with our whole fundamental theorem of calculus part 2, but I want to remind you, if you're finding a second derivative of something where there are two functions, maybe you'd call them f and g multiplied together, how do you find that derivative when we have, I don't know, a product? Okay, so you guys are going to write in the answers here to Edpuzzle. All I need is the second derivative. So take the derivative of this function. That should get you to the second derivative, and we'll go over it in class. So again, thanks for watching. We're going to try these AP style ones below, which is obviously where it really comes up, and how AP will utilize fundamental theorem of calculus part 2. Okay, and just make sure you're comfortable with what we've done so far in that pattern of canceling out derivative, antiderivative, and how we proceed with the problem. So again, thanks for watching. Let me know if you have any questions.